So do you have a mic? Do you have a hand mic at least? Okay, so he's going to introduce us. Probably not have this on right now when we're chatting with you, right?
And then we walk over here, and then don't start talking about it until like I'm ready with the.
Good morning. Oh, yes. Here we go, the final academic event of the SSP14 session.
Let's go back.
This is going to be a great day. Thanks for all coming. We have some special guests, but this is going to be a wonderful event. And as you know, these are the final presentations of the 4 team projects that the 122 participants have been working on for the last, 9 weeks, just about 9 weeks. My name is David Kendall. I'm the director, and along with John Connolly, the co-director, we'd like to welcome you to this final event of SSP14 here in Montreal, and especially with respect to our 2 host institutions, ETS, which we are, of course, here right now, and HEC Montréal, where we will be tomorrow for the closing ceremonies. So this is a great day, always a lot of fun, and always a chance to learn a lot about the 4 topics that we have. Just to let you know, we have a distinguished panel of people here who will help us to grade and mark and feed back to you their comments on what you will present today. I'd like to just recognize them, please. Of course, there's John Connolly, the co-director. There's Walter Peters, the president of the International Space University. We have our very own Jim Burke, who is with us again this year for the 28th year of these events. So thank you, Jim. We have Jim Crocker, who is the vice president and general manager of civil space at Lockheed Martin. And you will hear a little bit more from Jim tomorrow. He's one of our distinguished speakers at the closing ceremony. Somebody who you know very well, Su-Yin Tan, who is the chair of the Space Applications Group and, of course, a faculty member of ISU. So, Su-Yin. Dennis Irwin, the dean of the Russ College of Engineering and Technology at Ohio University and our host for next year. Ram Jaku, professor in legal department of McGill University. Michael Simpson, the executive director of Secure World Foundation. And Michael was the president of ISU before Walter took over. And last but certainly not least, Randy Sweet, the director of business development of Lockheed Martin and an ISU board member. And I'm sorry I forgot to mention, just walked in, Lucy Stoyak will also be helping us. You know Lucy, one of the local organizing committee from HEC. Thank you, Lucy. We are extremely fortunate to have some very strong sponsors for all of these projects this year. We will start, as you know, with Open Innovation and Space, which is sponsored by NASA. And I will now, actually we'll have Mike O'Brien joining us. He will come in a little later this morning. He got delayed. He's an associate administrator at NASA. He will be joining us, and you will be meeting with Mike tomorrow in a special meeting in the afternoon, as you know. But let me start off right away by giving the floor to Oscar, who is Oscar Gatuna, who is, of course, the chair of the Open Innovation team. Thank you, Oscar.
Thank you very much, David. Thank you for everything, in fact. I think it has been a great program so far. Good morning, everyone. It's my pleasure to be here. I'm a graduate from the class of 1999, and I had the privilege of chairing the Open Innovation Team Project this summer. We had 33 people in our team from 15 different countries, and it was a fantastic experience for me to see how they united as a team with this passion, with this desire to show us a different way to approach innovation. A quick word of thanks to NASA headquarters. As David mentioned, they've been supporting us. They gave us valuable inputs. Very big thank you to ISU staff, faculty, and all the visiting lecturers. Quick thank you, a quick and big thank you to Matthew and Julien for helping me motivate the team. They did a great job, I think. And of course, the biggest thank you goes to the participants. I think I'm pretty happy, actually very happy, with the intellectual output that you will be seeing today. But more than that, I think I was particularly pleased how they banded together as a team. They respected each other, they cared for each other, and I think they gave me a true glimpse of the magic of ISU. So this is their moment to shine. I don't want to take too much of their valuable time. So ladies and gentlemen, I present you the Open Innovation Team.
Hi there, Anne.
Hey, Rory, how are you?
It's good to see you. I didn't realize your company was sending somebody to the conference.
I know, I'm really excited to be here at the TEDx conference for Open Innovation, but gonna be honest, I've been studying Open Innovation for the past 9 weeks, and sometimes I still feel like I don't really get it.
Yeah, tell me about it. Open innovation it's a bit of a nebulous concept, but I mean, I think we got about 10 minutes for presentations are supposed to start. We can sit down and talk about it for a little bit if you like.
That would be awesome. I'm gonna grab a pen and paper.
So if we're going to talk about open innovation, I think it's important to start with a definition of innovation itself. Now, a popular image for innovation in popular culture is the light bulb, but I can't say I really subscribe to that. I think that innovation is truly a tale as old as time, and a better way to imagine it would be to look back to the invention of fire. And I think that's a good place to start, is the distinction between invention and innovation. Now, invention would have been the first time that a caveman was walking through a field and a lightning bolt lit up a wildfire. And he took a stick and he reached in and he realized he could take a piece of this fire away with him. Now, innovation truly takes place when he finds a market for this, or maybe 2 markets, 3 markets. So there's obviously been a few developments in the field of innovation since the invention of fire. And there's been a couple attempts to articulate what innovation really is and find out how is it that we get this thing that we're looking for. Now, a great way to go about imagining this is using what we call the value chain. Now, value chain starts with research and development, so new ideas. Then we move on to applied science and engineering, so development on those ideas, and hopefully with the injection of a bit of realism. Then we move on to manufacturing, where we build or construct our new product. And then we have to sell our product into the market. So the idea of taking ideas to the market is what we call innovation. But how do we drive innovation? How do we get more of it? Now, the first person to make an attempt to really define this was a man by the name of Joseph Schumpeter. Now, Schumpeter put forward the idea of techno-push, which essentially states that more ideas drives more innovation. The technology pushes. So if we put more money and more effort into research and development, we get more innovation. Now, this is a bit of an abstract concept, so I think it's important to look at a bit of an example for this. Now, let's look back to how the invention of the internal combustion engine led to the innovation of the motor vehicle. Now, Henry Ford is famous for saying that if I asked my customers what they wanted, they would have asked for a faster horse. And I think this really kind of captures what is special about innovation that can be modeled by techno-push. And what we call this kind of innovation is disruptive innovation. And that's because, just like Mr. Ford said, it's an innovation which is taken to a market that does not currently exist and disrupts the market that is currently in place. Now, techno-push and Schumpeter are not the only game in town. Schumpeter had a student who he assigned to actually prove his theory, but it backfired a little bit on him, and the student decided to come up with a theory of his own, which has since competed with it. So to imagine that, we're going to go back to our value chain and introduce Jacob Schmuckler. Now, what Jacob Schmuckler said was that demand pulls innovation. And so it's truly a larger market which drives innovation. Now, again, I think it's important to look at an example for how we can imagine this in order to kind of really cement it in our minds. So let's look back to the 19th century when we were first looking at using new surfaces on roads. This was back when we were still using horse-drawn travel, and our horses were driving our economy in a very literal sense of the word. Everything used horses. And now, we had better roads, but the roads weren't better for the horses. They were skating all over the place. The horseshoes were not well suited to these new surfaces. And so there was this enormous market need for horseshoes. 17,000 patents for horseshoes. I mean, really, how many different ways can you imagine that? But the demand was so high and the appetite so large for ideas that it drove innovation. Now, it's a very particular kind of innovation. It's different than the kind that we modeled with techno-push because we're talking about a market need that exists already. So what we call this is sustaining innovation. So innovation which applies to an already established market gap, market need. Now, looking back at our value chain again, and the next step on the route to a more modern view of innovation, Schumpeter and Schmuckler both look at innovation as ideas flowing from research and development down to the market in a straight line, in a linear sort of way. But two other scholars by the names of Winter and Nelson came along and suggested that, you know what, innovation is messy. That there isn't one place that really consistently serves as the impulse for innovation. You can get innovation being pushed from the manufacturing sector, you can get it being pushed from the engineering department. And the impulse can come from anywhere. And so we're going to take away all those blocks in the middle because frankly, they're just confusing now. And so what we're left with is a funnel where we have ideas coming in one end and the market down at the other. Now, what Winter and Nelson, Schumpeter and Schmuckler all have in common is they look at taking our ideas to our market. And any of our ideas that don't fit into our market are lost. It's lost value. We invest in these new ideas, we try and develop them, but we're not able to find a way to really make any money off of them. And so what open innovation proposes is that we start looking through the boundaries of our company. We start putting some holes in our funnel. And that's going to allow us to take those ideas and harness them, bring them to markets that we wouldn't have otherwise been able to exploit ourselves. And on the flip side, if we look at that from the receiving perspective, we can take ideas from other locations, fully develop and proven ideas, and then we can take them and we can apply them to our markets. So we can take ideas from the inside out, and we can take ideas from the outside in. Now, just like techno-push and demand pull, this view of innovation had a father, and his name is Henry Chesbrough. And he proposed that value can and should be co-created. Now, continuing on our little theme that we've been working with here, I think it's important, once again, to look at an example to really kind of cement this in our mind. And because this is, I mean, as we were talking about before, it's a bit of a nebulous concept. It's kind of hard to pin down. We're actually going to look at two examples. Now, the first one is the company that made the Canadarm. MDA. Now, MDA was at one point approached by Universal Studios with a market need for an animatronic dinosaur. Now, MDA brought the expertise in high-precision robotics, something that Universal Studios did not have the time or the effort or the background to invest in. I know Universal Studios brought experience with special effects, and it also brought the market need. And so by working together and co-creating this value, they were both able to benefit. Now, the next example that I'm going to look at will be familiar to all the gamers in the room, the Xbox Kinect. Now, when Microsoft first brought the Kinect to market, what they saw was a new way for gamers to interact with their console, a way to replace and/or enhance the game controller. But what hackers saw was a whole new way for humans to interact with technology as a whole. All of a sudden, machines are able to interpret our gestures and our body language. And by opening up their technology and making it available to these hackers, by embracing and supporting these outside collaborators, Microsoft was really able to capitalize on this and capture some markets that otherwise would never have been accessible to them. Now, I think two really poignant examples of this are in retail outlets, where store owners were using the Kinect to analyze how and when customers were interacting with their displays. Were they reaching out and touching it? Was their body language showing interest or boredom? And another more, perhaps, public good point of view, we had hospitals and old folks' homes that were looking at analyzing subtle changes in posture in elderly patients to see and hopefully predict and prevent dangerous falls.
Ladies and gentlemen, your attention please. The conference is about to start. Please take your seats.
Well, I think we're almost out of time, man. But I think if I had to sum everything up, it would be that open innovation is the strategic sharing of ideas for the co-creation of value.
Glad I run into you, Rory. Thanks for explaining open innovation to me. Now I really understand.
Good morning, ladies and gentlemen. How are you all feeling today? Well, fantastic. I'm glad to see that so many people turn up for the first ever conference about open innovation in space, the first conference about, and it's at Montreal today. I'm glad you all showed up here, because we have an amazing program. But first, before talking about the program, let me thank you, the team who put this all together, the local organizing team of this conference, who made sure that everything is okay, that you seated well, that the temperature in the room is nice. So thank you for the whole team. Okay, so let's get started. We have an amazing program. We have 3 presentations from 3 different sectors. It's all about open innovation. First, we start with open innovation and evolution. And we have Professor Dr. Karim Alive and Professor Dr. Louis-Étienne Dubois, both from the Innovation in Space University, or ISU in short. And then we'll talk about open innovation and how you can apply it today, so in the non-space sector, in the terrestrial sector. But then we make a link, because it's all about open innovation in space. So we have 2 other experts, Mr. Yang Xiu and Mr. Sebastian Marcu, both from a company called Innovative Space Solutions, or ISS. And they will share their expertise about how to apply this open innovation concept to the space industry. And lastly, because we have all the theory, we need the practice. We need something to apply it to. And that's where I'm very happy to tell you that we have got 2 experts, Mr. Mark Lander and Mr. Dapeng Liu from Open Mining Group, who will talk about how to use open innovation for asteroid mining. So with this, we have the theory in the non-space, we have theory in space, and we have an application to bring you the whole package of open innovation and how to bring it to space. So let's wait no further, but start the presentations. So the first presenters will be Professor Dr. Karim Alive and Professor Dr. Louis-Étienne Dubois from Innovation in Space University.
Thank you, William, for inviting me here today. Good morning, ladies and gentlemen. My name is Karima, and I'll be presenting you the open innovation strategies. So there are different strategies for organization to use and implement open innovation. The first one is the outside-in process that aims to bring external ideas, knowledge, and also technologies inside the company to create or improve existing products, services, and processes to create value. The second example is the inside-out process. The inside-out process uses the non-used technology, services, and also processes, and bring them outside the company to create value. Finally, we have the coupled process, the coupled activities, which are a combination between outside-in processes and inside-out processes. And this basically works like this. You don't do outside innovation by itself, and you don't do inside-out activities by itself. You combine both of them, and you use it to develop new technologies and to bring external partners all together to create something. So, to make it clear, I know it's kind of confusing, I will start with the example of Procter & Gamble. Procter & Gamble decided to use the outside-in strategy. Like I told you, the outside-in strategy aims to use the external knowledge from the crowd and bring it inside the company to improve your own products. Procter & Gamble set between 90 and 2000 the goal to double their revenues. Because they used to do all their innovation inside the organization, their R&D costs were very high. So to solve this problem, they decided to involve the crowd and use their knowledge to, with this approach called Connect and Develop. At the end, Procter & Gamble didn't reach their goal to double their revenue, but they finally had the opportunity to get all the knowledge from all this crowd, to multiply their partnerships, and also to improve their visibility. Another example is Tesla Motors, an inside-out example. Tesla Motors is an electric car company who was founded and is owned by Elon Musk, the CEO of SpaceX. So what they decided to do, basically, is to offer recently and to release electric car patents to the public. Why would the company release its own patents? Because they want other electric cars to grow, to be created. They want the market to grow. They want to develop the infrastructures of the electric cars. So, in this case, we can see that the real competitors are not the electric car companies. The real competitors are gas car companies. And this inside-out strategies shows well that sometimes when you give your patents, it's in your benefit to do so. Next, please. Another example of coupled activities is the CRIAC. CRIAC is a non-profit, for-profit organization that aims to improve the collaboration within the aeronautical cluster of Montreal. So basically, they bring different experts, different universities, also research centers, and private companies together to work on major issues of the industry. And how they do that is CRIAC serve as a physical platform for these exchanges. And when they work, all these partners work together, they are able to propose technologies, solutions for these major problems. And if they are able to find 2 different universities and also research centers that want to collaborate together, CRIAC offered 50% of the funding to these projects. Next, please. So, a good example of crowdsourcing. I talked about the inside-out process, I talked about outside-in process, and I talked about coupled activities. One good example is the crowdsourcing, which is also an OI method. What is the crowdsourcing? Is that is the act of taking a function once performed by your employees and put it outside to the crowd so they can solve and develop different projects and products for your company. A good example is the Fiat Mio, the Fiat Mio concept. So Fiat decided in Brazil to launch a car design, and they proposed to the customers and to the users in this platform to offer their ideas about their ideal car. So basically, through an interaction between users and all the different departments of the company, Fiat was able to design and offer a new car concept, which is called Fiat Mio, to the users. At the end, they didn't build the car, but this strategy brought to Fiat a big visibility, the ability to take 11,000 of ideas and from 160 people from different countries and bring them together to propose a crowdsourcing example. Next. Finally, the crowdfunding strategy. This is another one of the open innovation. You have basically somebody who has an idea, but he doesn't have the money. So what he wants to do, he comes to this app story platform and he says, here's my application, I want money. The users will look at the project, in this case it's a mobile application platform, and they will say, okay, I found this idea interesting, I want to fund it. So you have two different ways of contributing. A small contribution, which is a donation, and a big one. And the big one is usually rewarded afterwards. So to summarize, the OI strategies and techniques aims to use the interaction between the external and internal entities and to develop knowledge, technologies, different processes that by yourself an organization cannot do. So I will give the floor to my colleague.
Thank you, Karima. Engaging in OI is first and foremost a strategic decision. You got to know what you're getting yourself into. So what I want to discuss with you this morning are the benefits, but also the drawbacks, the risks, and the implication of pursuing a OI strategy. So the first benefit you'll hear when people talk about OI are having this possibility to access a bigger pool of talents, of people, of ideas, having many more possibilities to combine existing pieces, bits and pieces of knowledge, and to yield novelty out of it. So think of the grips here on the climbing wall as ideas. Do you want a wall with just a few ideas, a few grips, or do you want a wall like this? So what this gives you is the more ideas you have, the more exploration pathways and the more different trajectories you have when you try to make your way to the top. Innovation is about failure. So, you know, when you engage in innovation, you can be like good old Doc Brown here and, you know, fail on your own until you finally get to that solution, that 88-mile solution. Or you can decide to engage in OI and actually distribute the risk amongst different collaborators. What this is going to give you is actually a situation where you're failing faster because you got simultaneous failures. But it's not really the failures that matter as much as the fact that you're learning from each other's mistake, and that the faster you're failing, the closer you're getting to something that's actually good. So sharing and distributing risks that are inherent to innovation processes is certainly a major benefit. All right, does it make sense financially? How does it impact my bottom line? Well, OI makes sense financially. So of course it's about making new products or services or processes that are going to help you fetch a bigger share of the market, a bigger slice of the pie. You can also be thinking about OI as a way to increase the pie for everybody. But as you have seen in the Microsoft Kinect case, OI can also mean having others bake you a pie in which you can actually have a significant slice. So think of it as certainly a good way to increase your profit. And maybe one last benefit when we talk about OI, we're talking about making more efficient innovation processes. And one of the ways you do that is by engaging with external actors, users and customers, throughout the entire span of your process. What this yields, or what this ensures, is that you're actually making a product that has a purpose, that actually solves a solution that people want. Otherwise, you may end up building something like this, and only when you release the product or service, you realize that you've isolated yourself from external insights and important information coming from your environment that would have told you to start with that nobody wanted this. But hey, innovation, open innovation, is no free lunch. All right, it comes with drawbacks. It comes with important implications for your organization. So, in terms of management, when you engage in OI, you got to make sure that you got the internal capacity to handle the flow of idea that's going to come your way when you decide to invite on board tens, hundreds, thousands of collaborators. Hey, you're about to drink from an idea fire hydrant. Can you handle this? All right. So having the capacity is one thing. The other important thing is making sure that you have the culture that values ideas that are developed somewhere else. So your OI strategy means that you should question your norms, your beliefs, your values as an organization, and make sure that they're compatible with the collaborative and open premises of OI. When managers hear about OI, they think of this, right? It's just more people behind the leader who's going to help him get to his destination faster. So, I mean, it's about keeping control. It's still the guy in front that's steering this bicycle. It's just going a lot faster. Here's a better image. OI means, I mean, if you can tell me who's driving here, I'd be curious to have your theories on that. It's a lot less clear, and it means that your passionate customers, collaborators, users might take your ideas, your processes, and your strategies to unforeseen places. So, you want to fight it, or you want to enjoy the ride. In terms of implication, what that means is that you have to stop controlling or wanting to control the entire innovation process, but rather focus the passion of these people. One important and often talked about drawback comes from the legal field. So as you invite people in your processes, as you open up your boundaries, as you share knowledge, ideas, and IP, intellectual property, as it should be in order to collaborate, well, you're exposing yourself to leaks, you're exposing yourself to opportunistic behaviors. So you want to be cautious when you engage in open innovation when it comes to what's valuable in terms of intellectual property. but you also have to balance it with the need for collaboration, with the need for transparency, with the need to have ways that aren't too protected in which we can actually have real conversations and real value creation. And one last implication here. It refers to the technical feasibility of the ideas that are submitted from a crowd that may very well look like this. So these are not your average employees. This is a crowd. This may very well be the crowd you're relying on when you open up your innovation process. So how do you screen bad ideas from good ideas? How do you screen and select the ideas that are feasible from the ideas that are just ill-advised and unsafe to pursue? This means that you want to start thinking now about how you're going to select people, what you're going to make them do, and when you take in ideas, how are you going to use your existing knowledge and expertise to turn this sort of input into ideas that have value and that are technically feasible. So there you have it, folks. You know what you might potentially get. You know what you're getting yourself into. And again, I want to remind you that OI is a strategic decision. Thank you.
Thank you very much, Karima and Louis Etienne, for this great discussion on open innovation. So, we have now a clear understanding, I hope everyone has now, of open innovation and different concepts. So now, how to apply these concepts, how to apply these open innovation concepts to space? Well, for this we have two new speakers, two new experts from Innovative Space Solutions, who will talk to you about how to apply open innovation in space. But before giving the floor to them, they asked me to show their company video, just to show how they work.
Okay, Elon. I'll call you back. Okay, Elon. I'll call you. Here at ISS, OI is not just a concept. It's a way of life. Just a concept. It's a way of life. A way of life that's also a concept. A way of life. Have I got your attention? Walk with me, and we can learn more. Walk with me, and we can learn more. Hey, CEO.
Hi.
Hey, CEO. Do people ever ask you why ISS is a great place to be?
Sure, all the time. Here at the ISS, we basically have no management. Here at the ISS, we basically have no management. Sometimes we don't. Until we do. And then occasionally, sometimes we don't. And then occasionally, we do.
Don't you remember? I'm the new CEO here. The point is, there's tons of opportunity for you. All you have to do is draw a new management structure, and voila. We'll vote on whether to vote on it, and once we vote on that, we'll vote on the real vote, and then presto.
Yes.
At ISS, we're international. Team as they contribute to amazing projects. Cooperate with your colleagues. Resolve interpersonal conflicts. Celebrate important milestones as you achieve project goals. At ISS, we put the fun in funnels. Apply for a job today.
So, with this introduction, I would like to welcome Mr. Yang Xu and Sebastian Marco to the stage to talk about applying open innovation to space.
Good morning. Good morning, everyone. I'm glad to here to introduce about applying OI to space. We are talking about the specialty, the benefits, and the market of open innovation in space. Space is special, and the space industry is special. this is why we come here. Here are some reasons for this. Space industry is high cost. According to statistics in 2005, 1 kilogram payload sent to orbit will cost 15,000 to 25,000 US dollars. And there are more monies for in-orbit operation and the ground station. So space is very expensive. This is only the club for millionaire. And it's high risk. From the launch of the operation in space and the ground station, every failure of the factor may lead to the failure of the mission. That will be very, very high risk. And because of the high risk and high cost of the space industry, that may be the only space-proof equipment is reliable. So many tests will be done before the site launch or the space flight launch into space. So that will be cost a long time. This is long development. For the factors above, we have space companies. They are almost very small and specialized. Why this? Because they only focused on their own domains. So the small company means they don't have the resources they don't get the money, they can't do whatever they want to do. So this is our conclusion. Why is this special? We have high cost, high risk, long development, small and specialized organization or corporation. For these factors, they highly constrained the development of space industry, but situation is changing with open innovation. So how open innovation helps the space industry? We have new ideas from outside the organization. We have more participants to share the cost and the risk. And with more resources involved, the time frame is decreased. So who and what is the benefit from open innovation in space? Here are the beneficiaries. We have private space. We have private non-space. We have space agencies. We have public. We have government. Before, in the times of close innovation, all these factors are isolated with each other. They don't have too much connections with each other. But open innovation changes everything. Here's examples for this. With new markets and the spin-offs, you see the line shows the connection and the interaction between two factors. And we have spin-in, we have resources sharing, we have new innovation strategies, and we have education, and we have more. Every factors can be connected and inactive with each other. Also, we have risks about open innovation in space. As we have discussed before, here we may lead to loss of control. Everything is lot of control. And strategic partner selection, we have low performance partner that may lead to long time quarrel and low efficiency. And we have management, the risk of management kills. And we have may lead to some problems of intellectual properties. Some legal issues about open innovation in space. There always have many laws, treaties, and agreements nationally and internationally for the intellectual property rights and export control. But to facing the time of open innovation, we needed to renew our legal system to support, to encourage the transfer of ideas and technologies. So this is what I want to say, and my colleague Sebastian will introduce you of the market in open innovation in space.
Thank you, Yang. Ladies and gentlemen, so my name is Sebastian Marco. I'm going to show you some of the market findings of our research, of the survey that we've done. So we reached out to about 125 companies and space agencies using basically external contacts and also the ISU network to contact these people. And we've received 14 responses from space companies and 5 from space agencies. And this chart shows some of the people that were happy to, and companies that were happy, and organizations that were happy to be shown in conjunction with this survey. So to run through the results, we basically discovered there's OI is already being applied at a lot of organizations and companies, and coupled with the other findings that there's an increased interest in applying OI in general. Generally, risk companies and space agencies don't feel that there's a large risk associated with OI. However, it seems that the legal framework is not yet in place to support OI, so there's some restrictions there. And do companies and space agencies feel that OI will disrupt space business? Well, there's an even distribution, so there's not really a clear line if it's going to be one or the other. So in conclusion, we can basically summarize. So the space sector is willing to apply OI to the industry. The legal framework is really the biggest problem, though I have to say the space agencies, they saw it less of a problem than space companies to the legal issues associated with OI. And benefits are not yet fully understood, whether it will lead to large cost reduction or increase in profit margins, so there's something to be investigated further. So what we did, we've charted different applications of OI using different sizes of projects and the complexity of projects. And we've identified different areas on this graph. So high complex, large projects would benefit from market stimulating challenges such as the X Prize, which is basically cash incentives to drive innovation and invite many participants to propose a solution. Then we have lead entrepreneurs who are basically like early adopters, like Richard Branson, that would take an idea developed elsewhere and create a new industry from that. We have another area that spans across the whole range of project sizes at medium to low complexity, using software development communities like hackerspaces and hackathons to drive innovation and solutions. And then we have platforms such as broadcast searches, such as Innocentive, where you can basically enter a challenge and ask and crowdsource basically for solutions and innovation. And then there's a fifth one, which is basically like procurement, but it's price-based procurement instead of doing a firm fixed price procurement to market. There's a large empty area here that we can see, which is not currently covered by open innovation incentives. But what we have found is basically this is where closed innovation mainly happens by traditional companies and contractors and subcontractors. And we see a large opportunity for open innovation in that area to happen. Though those companies that are operating in that field will possibly use open innovation within their projects. And that could look something like that. Here's basically how OI can be applied to different technology readiness levels of a project. So ranging from low technology readiness levels, using spin in basic research with universities and research centers, across to crowdsourcing and spin out development using industry and agencies. So the choice is yours. If you take the blue pill, things will stay as they are. If you take the red pill, you will realize that open innovation can be applied at all technology readiness levels and can be used by all players in the space industry. And you will potentially see the light at the end of the tunnel when you choose the red pill. We've established the hashtag AwesomeOI, where we invite you all to submit your success stories and your experiences with open innovation, and share it with us and share it with the wider community. And yeah, I'm looking forward to hearing back from you how you feel about open innovation. Thank you very much.
Thank you very much, Sebastian and Yang, for this great discussion on how to apply open innovation to space. So, 2 out of 3 presentations over, but it's, well, there is still more to come. By now you should have an idea of what open innovation is, I guess, how to apply it in the terrestrial sector, but also into space. Because open innovation, it's a difficult concept. Everyone has their idea about what open innovation is. So to prove this, prior to this conference, we went into the streets and we asked a few people about what they thought is open innovation. Let's have a look.
What do you think open innovation is?
For me, open innovation means thinking something what other doesn't, but it makes sense and disrupt the market. That's, for me, it's some open innovation.
Open innovation, I think it's a great thing because you not only use your employees to do your research, but you also can outsource it to external people, and therefore it's like cheaper to get a lot of information and you get potential customers involved at the same time. Woo!
I think open innovation are open door to the new world.
When I think about innovation, I think about companies trying to find new ways to either market their products or services. Really just, it screams thinking outside the box.
What is your definition of open innovation?
Maybe think out of the box, and maybe you can get spin-offs you never thought of before.
Open innovation is the selective sharing of key knowledge and practices between businesses to promote cooperation while still retaining intellectual property to compete.
Open innovation is the melding of resources, ideas, and collaborative thoughts from various groups, individuals, and companies to come together and make new innovative products.
That's the million-dollar question that nobody at all understands or knows. If I could answer that, that would solve an entire TP, about 30-some people's nightmares, and solve a lot of world problems. That's what open innovation is.
Perfect.
Is that good enough?
Yes.
So, with this small video, I want to introduce you to 2 very special people, Mr. Mark Lander and Mr. Dapeng Liu, who are part of the Open Mining Group and who have as goal to mine asteroids using open innovation techniques. So let's give the floor to Mark Lander and Dapeng Liu.
Okay. Hi everybody, thank you, Will. I'm very happy to be here today at the Open Innovation Conference. My name is Mark Lander. I'm the CEO of the Open Mining Group, OMG. And what I'd like to talk to you a little bit about is the economy for an asteroid mining mission, and talk a little bit about the steps and the milestones that would need to be undertaken by a company like ourselves. But I don't really want to focus on this. More importantly, I want to talk about open innovation and how open innovation could be applied to an asteroid mining company. And to that effect, I have my colleague Dapeng Liu with me, who's going to talk to us a little bit more about the specific analysis and calculations that we've undertaken when looking at open innovation in asteroid mining. So asteroid mining is quite a new economy. There's a couple of companies out there who have developed their forward-looking roadmaps, and what we have on the slide here is Planetary Resources' own roadmap of an asteroid mining mission. So in the center of the slide, we have a typical asteroid, about 500 meters in diameter, and if we were to go out and mine just this one asteroid, there's a couple of different benefits, opportunities that we can gain from that. Down in the bottom left corner of the slide, we're looking at mining the water from the asteroid. What that allows us to do is to take the potential fuel for spacecraft, to put into any future space stations, and for use out in space to actually extend the opportunities and the reach of what we can do in space. As we know, it costs roughly $20,000 for each liter of water that we want to send up into space, and that's quite cost prohibitive in terms of a number of the things that we'd like to do. So if we can mine the water in situ and use it there, this is going to be a great advantage for us. Likewise, in the top right-hand corner, we're looking at actually mining for metals. So be that iron ores that we can use to develop the fueling stations or any future space stations and use it there in situ, or taking the platinum group metals that are available on these asteroids and bringing it down to sell here on the terrestrial market. And just to give a bit of context on that, one asteroid like this, 500 meters in diameter, potentially has close to double the platinum group metals within this one asteroid, double what we've mined in the history of this planet. So there's a huge opportunity if we can bring this down to Earth. For us, the first stages of our business plan is really to look at the water, and then in the future to move on to mining for metals. So looking at the key milestones that an asteroid mining company like us would have to go through, moving from the left to the right of this slide, the first thing is the identification and the detection of the asteroids. So there's a constellation of telescopes out there in space, which is constantly scanning the sky, looking for asteroids that have the potential to be mined. There's roughly 11,000 asteroids that have been noted to date, and this number is increasing all of the time. But there's an awful lot of work involved to actually scan and to find these asteroids. Once we've done that, we move on to the tracking phase, where we're starting to really obtain some data which can be useful to us. We want to undertake flybys of the asteroids that pass between the moon and Earth, so we can start to understand those. Thereafter, once we've selected the asteroids that could be of interest to us, we need to characterize those. The characterization process can include looking at the size, the shape, the rotation, the surface of the given asteroid, and we're starting to accumulate a lot of data which we can then extrapolate and really start to understand, is this the asteroid that we'd want to actually send a mission to, and eventually go out and actually start to mine the asteroid there in situ in space so that we can use its resources. Okay, so then if I open up at the bottom of the slide here, these are the open innovation methods that we can apply across the 4 milestones that we have in an asteroid mining company like ourselves. One of the important things that I'd like to bring out is that, and as you can see, the open innovation methods can be used right the way along this timeline, and it's very much a two-way street. So we're gaining benefits from the companies, the people that we're collaborating with, and we're also giving benefit back to them. And this is what open innovation can do for us. So we've heard about a couple of these different open innovation methods, but I'll just pick them up one by one and apply how this might be used in an asteroid mining example. So in terms of big data mining, what I've talked, especially in the characterization as well as tracking phases, there's a lot of data that's going to be available, and we need to understand how we can organize, extrapolate and manipulate that data to really understand the business and which asteroids we want to go out to. And we can use experts, people from outside of our company that can really help us to develop the algorithms that we can really benefit from this data that we're collecting. In terms of crowdsourcing, this is using people in the wider community, using their expertise to help us to do our work. For example, with the identification of asteroids, if we can have more people that are looking, there's a lot of work involved, and if they're looking, scanning, we can identify a lot more asteroids, and this is going to be to the benefit of our company. Likewise with crowdfunding, this is about going out to the general populace and getting money now. For them, they'll receive a benefit later, but we take the money now, and we can use that money to develop our business going forwards. And the sorts of things that we've seen in the past is Planetary Resources have undertaken crowdfunding to help them to build one of their telescopes that they're putting out there to help them identify the asteroids that they're going after. Gamification down here, it's very cool in terms of developing a game which is relevant to whatever problems that we're trying to tackle, and having the gamers out there really trying to solve this problem. And if they have some success, then we can track what it is that they did to resolve a given problem, and then we can use that and we can benefit from that and apply it to our own real-world life examples in asteroid mining. So that's gamification. Prize models is very much like the Lunar X prizes, and we find that if, for example, with drill bits, we go out to the market and we introduce a prize of, let's say, $20 million for different entities to develop the drilling bit that can be used in space in an asteroid mining mission. Quite often they can do that more cheaply than we would be able to do it in-house in silo, and paying them the prize is actually going to be more economical for us than we can use the drill bit in this case for our own business. It's a cheaper way of really tapping in and having others resolve the problem for us. And then over on the right-hand side, we've got coupled activities and fab labs, which is very much about bringing the different expertise, the different knowledge, people together into one room to help to solve and resolve different issues that they and we might be grappling with. And it's really about, again, getting the benefit of the different people, because we recognize that not all of the intelligent people work in our company, and we want to be able to open up and involve them to help us to resolve any problems that we might be grappling with. And then publicity partners down at the bottom there is, there's universities, there's other entities who would be, other institutes who would be interested in working with a company like ours, having their name associated with it, and this is another open innovation technique that we can actually tap in with them. So there's a number of different techniques that can be used right the way across the mission phase. We've undertaken a SWOT analysis of the overall open innovation methods, and some of the findings that we've come out with is the strengths of open innovation is really about finding your partners. It's about tapping into the intelligence and the expertise that's out there, and it's helping to reduce the costs, to reduce the timeframes, and to potentially reduce the risk as well. In terms of the weaknesses, it can bring additional challenges with regards to the logistical and the managerial complexities that you have to deal with when working and collaborating with others. The opportunities is really to start to understand the trends that are happening both in our marketplace and in others, and then, as I've said, bringing in the intellect and the ideas from outside. But then there's obviously inherent threats with that in terms of giving out our intellectual property, and for some competitors potentially to understand our core capabilities. So we really need to manage that. So one other thing that we've done as part of our work has been to develop a tool specifically to help management and to help decision makers really understand which of these open innovation methods along the bottom could be relevant for them, depending where they are in their overall journey. And with that, I would like to hand over to Dapang, who's going to talk a little bit about some of the analysis that we've undertaken.
Thank you, Mark. And with the tools that we have developed and the data that was available to us, we have undertaken an analysis of different open innovation methods. Our calculation based on the 3 different methods. They are crowdsourcing, price models, and crowdfunding. According to statistics, the asteroid identification community has reached 600,000 members now. So use these community resources, we can save our human resource cost by the community to help us for searching the useful asteroid. And by price models, we can develop the drilling and the other key technologies for asteroid mining faster. So with these two methods, we can save $32 million cost and shorten the schedule at least 1 year. Then we can use crowdfunding. It can offer us the upfront investment at least $9 million. If you don't believe, we can have a test here. Who want to pay for the naming of a new asteroid by your name? Raise up your hand. Okay, the beginning price is $10,000. Who will pay more? What? $15. Okay. 50,000. Okay. Okay. Now you see our business began. And Michael, you can pay the $50,000 after our presentation, and we will carve your name on the new asteroid. And based on this relevant conservative data, we have compared the different financial appearances of using closed innovation and using open innovation in the same asteroid mining project. This project is sponsored by NASA, and it is to bring and transport water from asteroid back to the LEO spacecraft. Oh. In this graph, the x-axis is year, and we can see the project will last 24 years. And the y-axis is the cash flow, and the curve is the cash flow curve of two situations. The blue one is closed innovation level, and after our calculation, the net present value NPV of closed innovation in the discount rate 2.5%, the NPV will be $2.3 billion. But when we use open innovation, the curve moved to this. And we can get profit 1 year earlier. And the NPV of use open innovation will be $3.3 billion. That means with open innovation method, we can increase $1 billion. And I know for most of you guys, $1 billion maybe it is not a big number. but for me, I think it is really a big number for me. So we can see use open innovation method. We can the profit level can be improved obviously. Thank you, and I'll pass back to Mark.
Thank you, Depang. And I think in the last couple of minutes, you've just made $50,000 for the company, so you've done a good job there. So just to wrap up quickly, obviously using open innovation methods in asteroid mining company is going to have its issues and challenges. One of the things is finding the right partner, and I stress the right partner, not just any partner, and we really need to concentrate on doing that well. And then we need to control the dual use of technology and ensure that any of our partners isn't using our technology for malintent. Thereafter, there's the legal framework. Obviously, the property of the asteroids, that's something which is still to be discussed. The Outer Space Treaty really sits across this, and if you're interested in law, you'll be aware. And it's really then the legal framework and the contracts that you need to make sure you put in place with your different partners that you're working with, and make sure that you're managing the intellectual property issues as you use different OI, open innovation methods. So in conclusion, open innovation can be applied to all of the different phases across the mission. As I said, it's a two-way street where you're giving and you're taking the value as well. Open innovation can have concrete and positive effects for your organization. That can be in terms of reducing the schedule of time to market. It can be it can be about reducing cost and increasing the profits of your organization, and gaining investments up front so that you can fund ongoing projects. There's obviously challenges as well, and you need to take a balanced view as you're considering open innovation methods for your own company. So thank you very much, and at this stage I'll hand back to William.
Thank you. Thank you very much. Thank you, Mark. Thank you, Dapeng. So with this, we come to the conclusion of our Open Innovation in Space conference. Yeah, I know it goes fast when it's interesting, isn't it? During the previous presentations, I made some notes, and I will present you the conclusions and the recommendations I made during these presentations. I think key important is to know that space companies should consider how they can use and how to apply open innovation. I think it's clear that it can be applied, but people have to, the private companies have to see where can they be applied. It's also about finding the right balance between open and closed innovation. It's not all open innovation or all closed innovation. You have to see where you can apply open innovation. It's also to see where, in what technology readiness level can you apply open innovation. Important is also for the United Nations and other regulatory bodies to think about the current legal framework and to accommodate open innovation, or to make it more easy to apply open innovation in the space sector. And as you can see, it's a relatively new field, so researchers should do more research about how to do open innovation in space. And with this, I would like to thank the speakers. I would like to thank the Open Innovation Conference team for organizing everything. And I would like to thank you, the audience, for being here and for attending our conference. Thank you very much, and I would like to get the speakers back on stage for some questions. Thank you.
So, any questions? I think the microphone is over there. Yes.
So give him that one, and we'll use that one. Yep.
Well, thank you very much for that presentation. So, right at the end there, I was struck by the word open. And let me just phrase the question this way. For some, the word open is a very positive quality, and it puts people in a proper mindset. For others, there's great hesitation because of, as you've mentioned in challenges, malintent, that sort of thing. So do you feel that having the title Open Innovation in pressing forward for either adjustments to policy or whatever is potentially a positive way to go, as opposed to tackling this specific item without labeling it as open innovation, which will yield perhaps more progress in what you wish to achieve?
So if I understood the question well, I think that for me, as I've gone through this journey over the last 9 weeks, open innovation, it seems like a number of the concepts aren't particularly new, but it's really a state of mind and a way of doing business, and really making sure you're considering all of the options and all of the different people out there and expertise that you can bring to the table. So I think in terms of the name and being open, I think that's not an issue as far as I can tell. But I do believe that we need to take a balanced view, and we need to make sure that whatever it is that we're doing differently and however we're opening ourselves up to the public at large, and that can include our competitors and different disruptive technologies that might be out there. We just need to make sure that we're understanding the implications, and we need to understand that we're managing the risk associated with that. Yeah.
And to complete his answer, I think that when you take the industry, nowadays all the different countries or all the different companies usually are closed. And why the open innovation concept comes as with this name is really to put itself in contrast with the closed model, where usually people work only individually, the companies work separately. But nowadays the open innovation shows that it's not only your industry. You need to open up to other industries. You need to open up to other international partners. But this presentation has tried and strived to show that there is a balanced way of doing it. And even if it's called open, there are different ways of opening up. There are also different steps and stages where you can open up.
Okay. Next question, please.
Yes, actually, I have two questions, one pretty specific, one more general. First, on the analysis near the end of your presentation on the comparison of OMG's open source solution to NASA's solution, your impact was primarily linear. Obviously, you're only working on the cost reduction side. Did you look at the possibility that open innovation would change the shape of that function through dynamic effects?
I try to answer this question, and in my model, in fact, I haven't considered that what you said, but we just do a very conservative calculation to show how open innovation works, to show how open innovation can improve the profit level. But yes, your suggestion is very important. That maybe after our presentation, we can do more deeply work to research that we can change the shape of the curve by use more open innovation ways, I think.
Thank you. And then related, but a much more general question, a lot of your focus was on developed countries and industries within developed countries, and yet open innovation would seem to be an interesting way of speeding emerging space countries' entry into the space sector, simply because they could innovate among themselves and therefore overcome some of the innovation deficit. Did you look at that side of the issue?
We have worked on with different companies on different cases, also Chinese companies, Indian companies too. And we have seen that it's really an international concept. It's something that's happening everywhere. It has different names. It's not something that came up nowadays. Today we have a name for it because we have different methods that we can acknowledge. But in China, for example, you have a company that uses these techniques to involve the crowd, because the open innovation is a tool, is an approach, is how you see things. It's not applied only for developing or developed countries. Everybody's facing nowadays the same challenges because of internet, and people are interconnected through the digital revolution. So what is important is to acknowledge the fact that everybody is affected by this, but companies and also governments, any entity reacts to it differently.
All right.
First of all, congratulations, an excellent presentation. Just to follow up the first two questions I have, and you have also identified very correctly, the legal constraints are the biggest barriers. I was wondering if you have open innovation on how to resolve them. If you don't resolve them, you can't reach anywhere in that. And I think in your answers to the previous questions, you mentioned it is open, other countries getting into that thing, not only within countries, countries, but also among the countries, that open concept. I think this is where the the biggest problem will be. I wonder if you thought about how to resolve those issues to implement your concept of innovation in space.
So legal protection is indeed an issue. However, in the report, we point out that it's only one of the issues and maybe not the most important one. In fact, we say technology, and we quote people on this saying technology is only 20% of the equation. The remaining 80% is the people. You got to get the culture right, right? And so what we're pointing to is that IP, of course, being an issue in terms of protecting your valuable knowledge, but that trade secrets will always exist, and that most often the most valuable assets will be protected under that form. What we're also pointing to is that IP can certainly inhibit OI, but it can also empower OI. When you look at patents saying signals to the market has the competencies that a firm owns, and so it's better, it makes it easier to identify potential and suitable partners. You can also see patents and intellectual property as sort of currency exchange. So I license you my technology, and you license me my technology. So it can actually also be a very good thing. So we ought to break out of this idea that IP is only a break to OI. And lastly, we also point out to new forms of protection, such as copyleft, Creative Commons, and these emerging forms of IP mechanisms that are also meant to foster collaboration, yet by retaining a property right on the knowledge itself.
Last question.
Yeah, it's Ed Crawley here. I want to distinguish two types of open innovation, which you carefully pointed out. One that has to do with knowledge and information artifacts like mining data and so forth, in which there's some unquestionable success. And the other has to do with the development of capital goods, of real products, real hard products. So the thing that's difficult to really understand is the distinction between open innovation, or the benefits of open innovation, and well-managed supply chains. Because many of the attributes that you ascribe to open innovation of capital goods actually would also accrue due to well-managed supply chains, like technology flow and so forth. So could you distinguish what you think are the primary differentiators between open innovation of capital goods and well-managed supply chains?
Thank you for the question. Again, once more in the report, we point out the difference being who you engage in, having a much broader view on who the potential providers of new insights and input could be. The nature of what you make them do, right? You don't engage with users just on their needs, just to have a better understanding of their needs, but you also involve them in the design, in the production, in the commercialization of your process. And the last little thing that really makes a difference is the intensity of the interaction. So is it just a superficial way to engage with outsiders, sort of glorified focus group, or are you actually having them create value with them, and in a transparent and collaborative way? So these are sort of the differences we make. And again, I guess the most important focus point would be there's no, as in a supply chain, there's no assigned role. Anybody can contribute to the process at any time. And this really what the open innovation process stance we've taken on this.
Okay, thank you very much. I think that's
Just to complete his explanation, if you take the innovation process. The beginning, at the early stage, most of the innovation is based on the ideas, how to generate the ideas. At the end of the process, you have the commercialization. So in between, you develop your products. What we have seen in the different cases that we studied is the fact that at the beginning of the process, this is where companies use the most open innovation, and also at the end. So in between, where there are all the patents, the product development, they don't use it a lot. So at the early stage, it's good to use open innovation because it brings you the ideas to your company. And at the end, it's good because it's also good for the commercialization, because you can go outside of your industry and affect other industries. So you can build an ecosystem that will get you back to the beginning of your innovation process, which is the generation of the ideas.
Okay, thank you very much for your attention.
Please thank this wonderful group.
Good job. Congrats, man. Well done.
Well done to everybody. This was a great start to the day. Thank you so much for the Open Innovation and Space team. We will reconvene promptly at 10 past 10. We're a little late, but that's fine. So thank you. Please be back promptly.